This standard is about multiplying polynomials. There's several different kinds of polynomials, and we're going to have different techniques for different combinations of them. First, we're going to start with multiplying a monomial times a binomial. So we'll do the distributive property with the 4x that's on the outside, and then the two terms that are on the inside. So first I'll do 4x times 3x squared. I multiply the numbers. 4 times 3 gives me 12. And then when you multiply x times x squared, don't forget that's the same as x to the first. So we could put a little 1 here if we wanted to think of it that way. So 1 plus 2 is 3, so that's 12x to the third. Next I'll multiply 4x times 6, multiply the 4 and the 6 to give 24. Don't forget the negative, so that turns into 24x. Next we'll multiply a binomial times a binomial. This is very common, so there'll be some tricks for this. So first we'll start with the distributive property. And the way you need to distribute is you'll distribute the first x with both terms in the second one, and then the second number here, the 3, goes to both terms in the second binomial. So first we'll do x times x, which gives us x squared. And then you do x times the 5, which gives you minus 5x. Then distribute the second term. 3 times x gives you 3x. And then the last two terms, 3 times negative 5, that's minus 15. Now you see here we can combine like terms. The negative 5x and the 3x both just have an x with them. So this turns into x squared. Negative 5 plus 3 is negative 2x minus 15. Now, this is so often done that we have sort of a shortcut little thing for it. What people often say is you'll use the FOIL technique, where F is first, O is outside, I is inside, and L is last. So if you think about what I said again, x times x, that was multiplying the first ones, right? And then the outside ones, and outside you think of as sort of being far removed from the middle of the problem. So the outside ones are this x and this 5. And then the inside ones are the 3 and the x, they're both right next to each other. And the last 3 and negative 5 are both at the end of their respective binomials. So first, outside, inside, last. That'll help you remember the order of the distributive property. So let's try another one of these thinking about the FOIL method. So I'm going to do the firsts, then the outsides, then the insides, then the lasts. So 2x times 6x, 2 times 6 is 12, x times x is x squared. Outside, 2x minus 7, multiply those, you get minus 14x. Inside, minus 8 times 6x is minus 48x. And then negative 8 times negative 7 is positive 56. So combining like terms, it's only one x squared, but I have two x's, minus 14, minus 48. It's like two negatives being added together. So that's negative 62x plus 56. Next we'll do a longer one, a binomial times a trinomial. It's still the distributive property, except there's lots to distribute to. So this x is going to go with the 2x squared, and then the x has to get multiplied by negative 6x, and then the x has to be multiplied by that 1. And then same deal with the negative 3. It goes to the 2x squared, the negative 6x, and the positive 1. So first we'll do x times 2x squared, which is 2x to the third. X times negative 6x, negative 6, and then x times x is x squared, and x times 1 is just x. Then negative 3 gets multiplied by everything. Negative 3 times 2x squared, that's negative 6, and the x squared stays. Negative 3 times negative 6x, positive 18x. And then negative 3 times positive 1, that's minus 3. So now I'll combine like terms. There's only one x cubed term, so 2x cubed. For x squareds, I have two of them. I have this negative 6x squared and another negative 6x squared, which will combine to give negative 12x squared. And why don't I cross out the ones I've done just to help make this less confusing? So I've done that one. I've done the two squared ones. And then for x's, I have a positive x and a positive 18x. Those combine to give 19x. And then all that's left is the minus 3. Next we have two special cases. Squaring a trinomial comes up a lot. What you need to think of when you see 3x minus 5 with the squared outside the whole thing is that means 3x minus 5 times another 3x minus 5. It's squared, that means you have two of them, so 3x minus 5 times 3x minus 5. And the answer to this is going to be found using FOIL. So once again, first, outside, inside, last. So 3x times 3x is 9x squared. 3x times negative 5 is minus 15x. Minus 5 times 3x, that's another minus 15x. And then minus 5 times minus 5 is plus 25. So now let's combine like terms here. 15x, 15x, they're both negative, so that's going to turn into negative 30x. So I have 9x squared minus 30x plus 25. After you've done a lot of these, maybe you start to see a pattern. What you're always going to have is the first term squared. So 3x times 3x is 9x squared. And it's always going to end with the last term squared. Negative 5 times negative 5 is positive 25. And then if you multiply these two terms together, you get negative 15x. And then if you double that, that gives you the middle term. Something that people often do when they say 3x minus 5x is they just square the first one and square the second one and call that the answer. 9x squared plus 25. But that's wrong because you've left out the middle term. You've left out this minus 30x. So do not do that. Make sure you write out the two binomials, square them, and get this minus 30x for the middle term. Another very common special situation is something called the difference of two squares. So you have two binomials here that are exactly the same as each other, except one has a minus in the middle and one has a plus in the middle. So let's square those out and see what happens. So FOIL, x times x is x squared. Outside, x times 7 is positive 7x. Inside, negative 7 times x, that's minus 7x. And then last, minus 7 times 7 is minus 49. So you can see what happens here. When you go to combine like terms, the 7x and the negative 7x, they cancel out. So what you're left with is x squared minus 49. So what you get when you multiply those out is two perfect squares that are subtracted. And subtraction is often called difference in fancy math words. So this binomial, when you multiply, gives you the difference of two squares. The way to do it without doing all the work out is to just square the first one, square the last one, and make the sign between the two of them a negative. Let's try another one. So 3x times 3x is 9x squared. Outside, 3x plus 2 is plus 6x. Inside, minus 2 times 3x is minus 6x. And last, minus 4. These guys cancel out again. So I have 9x squared minus 4. And you see I could have gotten that right from the beginning by just squaring the 3x, squaring the 2, and then putting a minus sign in between them.